Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
This is from a presentation by David Foster Wallace, which you can find on YouTube, and it's great. These two young fish are swimming along, and they meet this older fish, and he goes, "Morning, how's the water?" And the two young fish continue swimming along, and then finally one says to the other, "What the hell is water?" And what we want to do today is kind of give you an idea of the water that you'll be swimming in when you matriculate and go out into the world. If you don't need these slides, but if you're interested in them, you can find them at this URL on GitHub. So we're talking about all of these disruptive changes that happen, and I know that many of you are, reading the news and worried about what's this going to do to my career. There's, layoffs happening in these big companies and everything, and we have all experienced this thing many times, and yes, it happens. Our thing goes up and down, but always it seems to go up a lot more than it goes down beforehand. It can be cyclic, and the problem is really the way managers deal with these things, the way the management in general. So what you as a scientist and engineer needs to keep in mind is the idea of curiosity, to move yourself more towards curiosity, more towards I wonder and less I know. And you will discover that you will run into, especially if you're working for a company, people in upper management want everything to be deterministic because it makes them feel good. In the real world, most things are more complex than they are deterministic. So your watch, your computer, all of these machines that we make are deterministic. Complex is like the weather or a 4-year-old. There are things you can do, but you can't just go to a manual, or you can't just publish what the company's value system, what their culture, what the company culture is. This is a common thing. They'll say, "Well, we've decided what the company culture is, and so we published it." And then they wonder why nobody's adopting the company culture, because that's not how culture works. So my personal goal is to have less opinions. And what curiosity brings you to, and it's taken me most of my life to realize that I was stuck in determinism, and that curiosity is a much more fun way to live your life. And you learn more because you're open to learning. And eventually you get to experimentation. And I thought that I studied physics as an undergraduate. I thought I knew lots about experimenting. When we work with computer programs, we're always experimenting. That's what I thought. And then I've discovered that I don't like to fail. I like every one of my experiments to work. And I'm not experimenting if every one of my experiments work. Most of your experiments should fail if you're truly experimenting. And that's where you get your learning. It's unpleasant. It's hard, especially if you're attached to the idea of success. It's really hard. And yet the greatest benefit and really good feelings that you get is from experimenting and failing. Science, you're all scientists of some form, or at least that's probably what your degree is going to say. The whole thing about science is that it models causality. So we go, something happens and then this thing happens and we think there's a connection to it. And that is all science does. It creates models that fit data that you have and that are predictive. And if it can't do that, it's not very useful. But it's not talking about truth. I always thought science was telling us the truth, but it's just a model that gives us interesting data, and the model has to be falsifiable. I can assert that we live in a simulated reality, but how do we falsify that? How can we say that how do we test that, basically? So that's an example of that. So one of the things, I did not give you a heads up here. What we're trying to do, each of us are going to give a talk that's about, we hope, around 5 minutes long. And the goal is to produce questions from you. Should have said that at the beginning. That's what we're trying to do. So one of the things that, I mean, you're reading the news, you're hearing about, you're playing with these large language models, and you're going, oh, companies are firing people all over the place. Well, the managers of the companies are firing people all over the place because they think they know what's. That's another thing. What I want to talk about here is the fact that humans are super bad at predicting the future. And the ones who get up, are on television and things like that saying, oh, I know what the stock market's going to do. Those are statistically shown to be worse than the average person. And those are the ones that are up, telling you how things are going to be. And this is, if you don't know about cognitive biases, this is really useful because it shows you all the different ways that your brain can be tricked into making poor decisions and poor predictions and things like this. This is from Wikipedia. And so you can find it under, if you look up cognitive biases, you can find it there. And there are all these different cognitive biases. The book that is kind of the foundation for this is called Thinking Fast and Slow. And I know we're not talking about computer science here, but it's really, when I started as an engineer, I just said, the managers will take care of things. That's their job. I just heads down, I do my thing. And over the years, I've discovered that you really have to actually pay attention to everything. You have to be curious about everything, or else it'll get you. So the thing that everybody's really afraid of is what happens if we're able to produce artificial general intelligence, AGI. The thing is, we don't know what intelligence is, and we don't know if we can create it. That's all. Like a large language model is basically just a huge equation. You put some stuff in and it gives you stuff out. That's not intelligence. It can seem like intelligence. We don't know what AGI is. Maybe it'll happen. Maybe with LLMs, we can get closer to doing it, but we don't even know if it's possible. And you and your LLM buddy are going to be able to create more solutions. And there was an episode of Futurama where Dr. Farnsworth decides that all the problems in the world have been solved and he has nothing to do, and so he's in great despair. And that's the kind of information that you get from. Remember that the news, at least in America, we know the data shows that when you're scared, you buy more stuff. So keep that in mind. When you look at the news and it scares you, you just go, oh, they're trying to get me to buy more stuff. And they're not looking at the real stuff. They're just looking at what will make me buy more. So ultimately, the problems, there's so many more problems that have not been solved that we're not even paying attention to because you look at it and it seems too expensive. It's going to take too much trouble for the cost benefit. Now, we have these LLMs to help us build things. So you and your LLM buddy can solve all these different problems that nobody's even talking about now. But if you solve them, you can create customers. And that's ultimately what you want to do. You can look at this world in terms of, oh, I want to work for a big company and make lots of money from them. Well, in that case, the big company is your customer. You still have to have the capability to solve some problems. And for me, the solving the problems is the more interesting thing. We just have better tools now. That's what this produces for us. is these tools that allow us to solve problems that previously were too expensive to even think about solving. The bookstore in Crested Butte is using ancient software for running their bookstore because previously it would take a team of people to solve that problem. Now it could probably be done with one person and using an LLM, and there's a new market for you. And then there's all these other markets. All you have to do is look around and you can find problems that you need to solve. And so your skills that you're developing here are maybe the exact skills. Like I learned assembly language when I was going to school. I learned some higher level languages, but a lot of people were still using assembly language. And then compilers, high level languages come along, don't really use assembly language anymore. I still find it helpful to understand what's going on underneath, but I think the same thing is going to happen with you. All right, that's enough for me. We will now move to Bill.
Okay, that should work. Okay, that's my first slide. I have 5 slides, 3 of which are blank. So, so you know how much is coming. My name is Bill Venners, and the name of this talk was Adapting to Disruptive Technologies. And Bruce said that, I heard him say, humans are very bad at predicting the future. So I'm going to predict the future because I didn't know he was going to say that. So what I have noticed in the past is that when technology changes, people change without really trying, because if the technology offers you value, you just switch to it. And you gain something from that. But at the same time, what I've noticed is that we lose something too, usually. And I think that will happen with AI. And so what I wanted to do was give you 2 examples from the past of that kind of trade-off. So the first slide, hang on a second. Boom, there we go. So this is written by Bill Venners, but not by me. This is my great-grandfather's brother. My name is Howard William Venners. His name was William Harold Venners. He was born in 1888, and he wrote this letter to my grandfather, his nephew, in 1920 using a fountain pen. And a fountain pen, if you push down, it kind of makes a thicker line, and like when you do a loop, you'll lift up a little bit and it makes a thinner line, and you ended up with this it kind of facilitated or encouraged people to make this kind of beautiful handwriting you may have seen from the latter half of the 1800s, first half of the 1900s. And then what happened in the mid 20th century is ballpoint pens became widespread, and that was a new technology that everybody just started using because it was more convenient. And we gained a lot from that, but what we lost was that kind of beautiful, elegant, this stuff, right? So that's an example. And I had nothing to do with that because I was born and it was already ballpoint pen time when I was born. But what I did kind of participate in is in the mid-90s, everybody stopped writing letters like this because email came out and became widespread. I mean, email was out before, it became widespread in the mid-90s. Text messaging and long-distance phone calls became very cheap, and then they became free, and then they added video. And so we use that instead. We use this electronic communication. It adds a lot of value to our life. But we lost, to me, something that I valued, which is personal letters, handwritten letters, that I did what my grandpa did. My grandfather, this guy Earl, saved all the letters he received. I now have them. I also have all the letters I received up to about the mid-90s when I stopped sending them and I stopped receiving them. So we gained a lot with electronic communication, but we also lost something that was valuable to me, in my opinion, which was this kind of thing, personal letters. So to apply that to AI, those are 2 things in the past. So the predicting the future, the same thing will happen with AI because that's what I think, happens. And so for AI, I'll go to my next blank slide. I wanted to share with you an anecdote. This is not scientific, but I was in Switzerland a few weeks ago at a conference. There was a professor there, computer science, and he told me an anecdote that another professor told him. So this is third hand now. But what it was is that guy was teaching programming course. And he said now that AI is available to students, whether they're supposed to use it or not, their homework assignments are now perfect. So their scores went up for the homework assignment, but their test scores have gone way down. And the conclusion is that by delegating or offloading the programming assignments to an AI, you didn't go through the process to learn what you needed to learn to through the course. And that's how I learned programming. I learned programming by doing it. I didn't have the option of using an assistant and trying to decide when to use it and how to use it. So what I do use AI a lot now, and what I use it for, what I've noticed is I have to judge the output and edit it. And the way I judge it is because of my experience and my knowledge and my taste, which I gained by doing it myself, because I'm hands-on learner. So I just want to give you a few ideas of the way I use it that I think are useful. One is I use it as a virtual expert. So it's like a free, not a free professor, but I don't want to, it's like I can ask it questions and learn about topics that I'm interested in. And that's been really, I love that. I think that's been really beneficial to me. And I do a lot of asking it to write text and code, prose and code, and then I judge the output and I edit it. And I find that helps, but it is not always helpful. I mean, maybe it isn't always faster. And what I've been trying to do is train a model to write code and text like me, so that it's really make it not just like write good text, but write text like me. So I've made some progress on that, but I'm still working on that. So I guess I wanted to suggest that that for that we don't delegate to AI things we think we need to be good at, because we will miss the learning experience of doing it ourselves. You have to pick and choose. And so you need to be mindful of what it is you want to learn for whatever purpose it is. And then it's very tempting to offload that, but sometimes don't, right? Just to give yourself that. But on the other hand, I think everybody today needs to get good at using these. That is a blank screen still. Oh, I forgot to plug it in. That's fine. But anyway, we need to get good at using AI, because it's going to be ubiquitous. I might have to reselect my content here. And it is still blank. Okay, but you can see it. I took a lot of time to design that. I didn't use AI. So you need to use AI well, and that's got to be part of your education. And there's two sides to it, because one of the things, you need to know how to prompt it. You need to learn how to prompt it. So you need to practice prompting it, and by doing it, you will learn how. But you also have to be able to judge and edit the response. And to do that, you need to have the taste and the experience and the knowledge that you would maybe need to do it directly enough to learn that. Like, that's how I learned it. Okay. And then lastly, I wanted to suggest that I do think this will happen. That's my future prediction, that we may lose something that we value as we transition to AI, in addition to gaining something that we value. But that I thought about this, that there are ways you can still keep those things in your life if you're creative. So I realized that several years ago, I don't send handwritten letters anymore, but some strangers started asking me to give them handwriting, not with a pen, but with my finger. So I just started doing this. Like, whenever I have one of these things, like I'm checking out with a credit card or whatever, I don't just go, oh. I just try to like my great-great-granduncle or whatever, I sort of take the time to whoosh, just so I have a little of that in my life. So anyway, that is my talk.
All right. I'm Dianne Marsh. I am happy to be here. I am going to have some repetition from both Bill and Bruce's talks. But what I really want to talk to you about is embracing change throughout your career. My experience is that things change in this field very, very fast. And that's one of the things that makes it super fun to be here. But also to have a meaningful career, I think embracing change is the key element. So I'm going to go through a little of what I've experienced through change. But before I do that, I want to ask, how many of you are worried today about your job prospects in light of all you've read and heard about AI? I bet, right? It's a little scary to watch the news. I hope I think it's a reasonable concern, but what I hope that you all will take from this talk is that those of us who have been through it, you heard a little bit of this from Bruce, is that things change, and it's usually not quite as dramatic as what we hear today. I've heard about the demise of software development since the beginning of my career, and I graduated in 1986. So I'm going to go through a little bit of the changes that I've experienced and how they've made programming richer and how it's enriched my life. But I also want to really drive home the point that these changes have made it easier for us to solve bigger, more complex, more interesting problems by removing a lot of the tediousness and the repetitiveness that we had in early days to give us space to solve those bigger problems. So my first job, we didn't have Windows yet. And I know Windows is like gone way beyond what it was then, but this meant that we didn't have any way to do multiple things in a program. So, for example, I worked in a company that did analytical instrumentation. So we put a sample in a furnace, we heated up that furnace, we measured the elements that were in that sample, we analyzed that information, and we displayed it in a very rudimentary, user interface. All this had to be done by hand. It meant that nothing handled the fact that we were going to have to switch between measuring and analyzing and displaying. And so we had to manage that ourselves. So what did we have? This huge for loop that just incremented a variable and then went back to the very beginning. So a little bit of time doing some measurement, a little bit of time doing some analysis, a little bit of time doing some display. Back to the top and do it again. Don't spend any time in any one of those sections because then you're starving the other processes, right? You learn about this in operating systems, but we had to do this in my first job. Isn't that crazy? So, going to Windows and going to more modern programming languages and systems, the fear at the time was, oh gosh, everybody's going to be able to do this. We are not going to need as many computer scientists. It's just going to be so easy. Don't even worry about it. Of course, that did not actually happen. All we got to do was solve bigger and better problems. IDEs is another example of where people got really worried about, you're going to have code completion. You're going to have all this code that gets built for you automatically. This is going to let the masses generate good code. We're forgetting about the craft of understanding requirements and of bringing that to life in code and how that really takes a lot of your energy and a lot of what you've learned. Your solid CS fundamentals that you are learning here and that you will continue to learn throughout your life, that's what's going to take you through. It's not having a tool like an IDE. So I'm going to talk a little bit about some advances in continuous delivery and continuous deployment. One, because I and my team we're very involved with this, but also not because you should learn any particular tool today. But I think there are some parallels with AI that might be helpful for you to understand. So continuous delivery, continuous deployment allows the developer to actually deploy the code that they wrote. In a complex system, this is complicated, right? I might be committing code in a big system like Netflix, which is where my experience in this came from. And I might not understand all of the other things that are happening in that environment. So I need to deploy that code and make sure it's still working and then figure out if I need to roll it back. The unintended side effects can cause, quite a bit of disruption. And the tools that got built in part by one of my teams at Netflix, my first team, Engineering Tools, helped really democratize that process. Now, who lost their jobs when we did this? There were a whole class of people, roles called DevOps, which was very little dev and very much ops, that used to deploy code. And this was their job. And so those people were going to be displaced by such tooling. But what actually ended up happening was those folks found new jobs doing development, right? Then they got to do more meaningful work. And also they weren't in the horrible position of having somebody else's code deployed that they didn't know, they didn't write, they didn't understand, and then have to decide what side effects did this cause? What happened? Do I need to roll it back? Imagine that awful experience of, deploying something at Netflix scale and then not having any understanding of the code and saying, oh gosh, I need to roll it back or I don't, right? So yes, there were jobs that were shifted. And so I want you to think of a lot of the changes that are happening can either be helpful in helping us grow new experiences, new ways of doing our work, or a shift, which will shift some people from one aspect of the way that they engage with their work to another. And so that's what we saw with continuous delivery and continuous deployment. So is AI different than all of the things that I've discussed? Because I think that's maybe what you're worried about. So I've given you some examples through my career that I've been able to navigate. And you're probably wondering, gosh, but AI, that is way more different. That's going to, take us to a whole new place where life's going to be very much changed. Yes, it's going to change the way that we do our work in some ways, right? But it's going to improve our ability to solve complex problems that today and in the past we have not been able to approach. We need to be implored to embrace and understand what AI can do, and that is really going to be table stakes. Like Bill said, understand what it can do, understand the limitations, understand how to engage with it, just as you would work out how to understand and engage with these other tools. Like I said, AI is uniquely positioned to help us solve bigger problems. But the risk of AI is that if we use it without discerning what those actionable insights are that are coming out of it, we can outdrive our headlights. Much when you're driving a car, your headlights only go so far. Please don't drive faster than that. You get yourself in a big trouble. You can drive off a cliff and I could see the same thing happening with AI. So what I think your responsibility when you're working with AI is this insight correct? How can I validate this insight that came back to me? Is this correct? There's going to be a lot of work from computer scientists to try to are going to be needed to really validate those concerns programmatically. How can you look into this? There's a lot of work there. There's a lot of work to understand, is it free of bias? If we have a model that's introducing bias, we need to understand that. How can we build our systems to be able to dig into these insights and understand the bias that might be inherent in the model that we're using? And then, is the data reliable? Is it too small? Is it not reflective of the general population? Does it give us the information we're really, truly expecting and looking for? Okay, so I've talked a lot about all of these things. The one key, I think, to having a meaningful, satisfying career is lifelong learning. If you're in this field, you're basically signing up for continuing to understand changes that are coming your way, separating out the shiny objects from the really important trends that are coming. This is something you build over experience. Please don't jump at every shiny object. You'll never get any work done. You'll get fired, right? But also don't let big trends go by, because then you'll miss out on a whole lot of really interesting work. And you might end up doing the same thing for 30 years. And I really hope that's not the case. I've just retired, and I will tell you that the reason why I enjoyed this job so much is that it wasn't the same any time. During my career, I had so much change. I worked in many, many different domains. The ability to be able to apply your domain expertise in software development, computer science, to a variety of different domains in the world is incredibly meaningful. Makes your life made my life so rich. You can decide if it's worthwhile for you or not. And just navigating change throughout that time and new technologies and new ways of doing things, being able to solve bigger problems we didn't even imagine. Back when I was working in my little for loop that continued to increment variables to time slice through an application. So I hope that you will continue to embrace change. As Bruce said, stay curious and don't drive your career by headlines, because those things change. Anyways, thank you very much. And now I hope you're all ready for panel discussion.
All right, so I will carry around the mic and do a few audience questions for the remainder of our time. So just throw your hand up and out for room. All right. Brave soul in the back asking the first question.
So everybody have a seat, sir.
I'll get mine.
Or we could have that. Get the that one.
Do you have the other one? Grab the other left mic.
No, we can just pass that one around.
Oh, you passed that one.
Okay.
But only one person should talk.
Yeah,
Yeah,
I know it's gonna be tough.
Yeah, you hold this for a second.
Well, it's not on.
I know.
Okay. Yep.
Okay, so all three of you kind of spoke to embracing change and kind of moving along with change. I was just curious if any of you had any information on of the specific fields of computer science, software development, information security, and that which fields are being changed the most versus the least, like how those fields that are changing, like how they're changing, or the ones that aren't changing, how it was staying the same throughout AI.
So this thing on. Is there anything static? That's a really good question. Having worked in a variety of different fields, I can see change being introduced into all of them. I don't think that the AI is mature enough to be able to figure out where it may or may not be applicable. There may be places where it's overkill. Like it's guys, all right, it's overkill to search. To use search with an AI rather than just to Google, there's some extractions that are going to happen where, Google might decide, when you're doing a search to use the AI or not. Let that abstraction happen. You don't force everything through ChatGPT. It's just wasteful, right? So, I think things like that are going to work themselves out. But I don't think that the field is mature enough yet to be able to say, what's changing faster than anything else.
Our field is all about climbing up. Like I mentioned assembly language, and that's what people universally used to use. And there are scaling limits to every one of the technologies that we use. And we could build systems. I mean, they sent a man to the moon using assembly language. So it's like, it's possible to do that. But when you want a really sophisticated system, you run into those scaling problems. And I think all of what we do is try to build on the shoulders of what we've had before. So, and everything gets affected by that. I mean, like the Diane's example of the DevOps being replaced by CI/CD, it is, and that's because it works better. And ultimately because we can do something faster and cheaper. Even though I didn't want to think of it that way initially, I started realizing, yes, it is about economics. If a human can do something better than the computer, we're going to have the human do it. But once the machine can do it better, then we all move forward. Well, eventually, I hope we all move forward from that. Do you have anything?
Yeah, just one short thing. I was just going to say that when I talk to people of different, occupations, I always ask them how they're using it, and they always have some way of using it. So I think it's touching everything. So it's going to be something everybody needs to know how to use well.
I'll add one more thing.
Oh, okay.
I'll just add one more thing. Even outside of computer science, a lot of people are using it. So, my husband is a laser scientist, and he uses AI for a variety of different things, not for design, but he's using it for being able to consolidate complex topics and be able to understand them in a way and share that out with other people. So I think that the opportunity is growing for people who hadn't previously found a way to directly engage themselves with programming, to more directly engage themselves now with AI.
I need to add something.
Keep going.
Bill needs to add.
I just realized I lied to you, and I want to correct myself. I did talk to somebody who said they did use it, and there was a reason. It was they were worried about GPL code getting put into their output. So some people are choosing not to on purpose for a reason.
Well, okay, now I have to add something. So our friend Paolo Bacigalupi, who's a science fiction writer, we talked to him about it, and I thought he had the best, because he and I have argued about this for a while, and he had the best answer. He goes, I don't want to use it because I want the experience that I have of writing the book, of having it that's satisfying to him. I was like, can't argue with that.
Bill, for students who don't know what GPL means, what was the concern about that?
Getting public license is an open source license, and this was, I'll give you specifics. It was the Scala JS, the guy who writes that, and that in the Scala was written for JVM. So when they tried to download, compile it on JavaScript, that worked well, except people using Scala like to use Java API calls, so they have to re-implement the Java API to a great extent. If you ask an LLM to do that, he's going to go look it up with JDK, which is GPL, which means now the Scala phase would have to be GPL because of the license. It's a viral license that people try to, if they decide not to use something like that, they have to avoid them. So that's what that is. And the last thing I was to add to what I think Paolo, what I got from him is he needed that. It's kind of like I was mentioning where you may need to do this programming assignment to kind of go through the difficulty and learn. I think what he was learning was where the magic was in his story. He needs to go through the difficult pain of writing it over and over to learn that. I think.
Yeah.
Okay, good.
Okay. Hi. I have a couple questions. I hope that's okay. My first question is, how do you see people moving forward with working alongside AI and like working with autonomous AI? Because while maybe at this moment the AI is not terribly advanced, I think at the rate that we're developing AI, it will be capable of being autonomous like pretty soon. So how do you see that kind of like playing out, and how can we all keep up with that? Does that question make sense?
Yes, it's just really hard to answer. Go ahead, Bruce.
Well, I guess my answer, the short answer would be using AI. When AI came online, I was halfway through, I don't know, I was a month into learning the Rust language. And I had, watched lots of videos and experimented with it and everything. AI comes along and I'm able to start asking into, every time I thought of something, I said, write me a little example that does this. And my learning accelerated dramatically. And so in another month or so, I could read Rust code with, all the, bells and whistles, except maybe the unsafe stuff. Yeah. I've been experimenting with using it to write books, and I end up having to. It's a great research assistant, but of course, all the examples have to be tested. It doesn't always cover things. I have to ask it what's this mean, and have it add things, that sort of thing. I don't even know if it'll be worth writing books anymore, but. I guess ultimately is you experiment with it, you use it to help you keep up, and the other resources. I don't know if that's helpful.
I'm not sure that we're ready to be autonomous, and I'm not sure it's as close to autonomous as people think it is. I think that the key, as I kind of hope I brought out in the talk, is I think that the key is explainability. So you need to be able to explain, how you got somewhere. And we're not even close to unleashing, it to be autonomous. Much like I'll just go out there and say, I have a Tesla. It does not feel self-driving, and so I think, as we learn the limits of AI, I suspect that we will stop short of autonomous in most use cases.
Thank you. And then my follow-up question is, I guess since a lot of us are, scientists and engineers, we're probably going to be a large portion of the people that use AI in the future. how much of the like ethical and sustainable impacts of AI are going to be our responsibility? Do you think?
You ask such amazing questions. Wow. Such good questions. Yes, that's our responsibility, right? How much of it? A lot of it. You can't let the lawyers, be responsible for ethical and those limitations because they won't understand, the detail. Much like you can't let the patent office decide what's patentable because you get nonsensical answers as we have in the past. So I think that, yes, that's our responsibility. It's always been our responsibility around to make sure that we were acting in ethical ways. As far as sustainability, that's tricky. That's super tricky. Because I think that we're going to have to, that's going to take a lot of study. I don't know that I can answer that question. Maybe somebody else has an idea.
Mm. Well, at least in terms of our current LLMs, I think the direction is going towards having, instead of an LLM that knows everything, having specialized LLMs. And then, what's it called? MCP. Friend James, who couldn't be here today, he works at Amazon and he's kind of one of the leading researchers, I guess, within Amazon on MCP stuff.
What's MCP?
Model Context Protocol. So it's a way for one LLM to talk to another one. And so the idea would be that you would have a front end that would talk to some of these smaller ones, and because they're only focused on one topic, they're much more efficient. Now, in terms of the and moral responsibility, I guess, I actually I think historically scientists and engineers have been so focused on what they're doing and not paying attention to the, well, I'll just say it, sociopaths, psychopaths that get into positions of power and use this and start causing all kinds of havoc. So I think I don't know. I mean, yes, you're right. That is a super tricky issue because it requires us to actually take more control over these things. But ultimately, I think it's a bigger problem because we're talking about a systemic, structural system that rewards people who get into positions of power and decide to invade other countries, etc. And but that is a problem that is bigger than our brains so far have been able to handle. And that is a problem that I think the machines, which can hold lots and lots of things in their head. We were just talking about your roof here. When it rains, you can't hear anything. That's because architects are very limited and they only want to think about whatever they're used to thinking about. And so they can't deal with that. Whereas a machine can hold tons and tons of factors. And I think things like architecture is going to change. And I, fingers crossed, hope that organizational systems are going to change. And I didn't get to my last slide, but it was it's something that came to me this morning is, can we figure out how to build, because we're still using industrial age management. Can we come up with a way that people can work together in a self-organizing fashion without putting a hierarchy in? So I have hopes that these tools will allow us to get there.
Okay. I just wanted to say that I think it's good to care about that. Sustainability, social impact, environment, and I'll get back to this thing because it is expensive. One good thing I think is that the cost is kind of aligned with caring about that because, so for example, one of the things I've been trying to do is think about how I can make the context as small as possible. Because I've heard like as small as possible to be effective. I've heard it's actually more effective if it's smaller. That after a while, it's kind of like a person. You can't keep track of everything you put into context. And so I think there's a lot of, and there's just a lot of costs there with people trying to figure out how to make it do more with less. So that's a want. The other thing I thought about is that when I was a kid, they taught me to say please and thank you. And I always say please to these LLMs, but that actually has an environmental cost. But I just feel wrong. I haven't gotten over the hump yet to actually command it to do something without like being polite, but I probably shouldn't. So, yeah.
Okay.
Next question.
There was one over here. So.
I think she had to go.
It's not turned on.
Oh, it's just.
Yep.
Press it. Well,
Please.
Please. You
That didn't help.
want the last
You can
mic?
yell it and we'll repeat it if you want.
I was just, I guess you asked one open-ended question of what you guys think about synthetic data in AI. That's because of that is going down, saying AI data that is necessary and so.
Repeat the question. So
Yes. So the question is about AIs generating synthetic data, and I think
using it
and using it to train itself on. Yeah, that's an awesome question because I feel like there's probably some math signal theory stuff in there that would tell you that, well, maybe, who knows, maybe you could get a little way doing that, but at some point it's going to degrade. That information is going to degrade. I think that I hope that the next step in even just LLMs will be the ability for it to validate its own data rather than just generate new data. It would be able to say, and I could imagine it saying, I need to do this experiment. I have all this information, but I have a piece of data that's missing, and I need to do this experiment. And then I'll be able to fill. And we might not even be able to imagine what that experiment is because, we don't have that big picture that it might have. And if it fill that in and all of a sudden, now we've got fusion or something like that. But I think, yes, being suspicious of synthetic data is spot on. That's the kind of thinking you need when you're working with an LLM. One of my early experiences was I wanted to create a Python program that would do, I forget what it was, but anyway, asked it to do this, and it wrote me a program, and it said, all you have to do is bring in this import this library and then use it and everything. It took me a while to figure out that library didn't exist, and so it's always it. And the interesting thing is this process has made me understand what science is. I did not even though my undergraduate degree was in physics, I did not understand what science was. It is this model that has to fit the data, has to be predictive, has to be you have to be able to validate it, and you have to be able to disprove it. You never prove it, but you have to disprove it. So that's the kind of thinking that you need when you start dealing with any of these systems is, great, maybe this will work. I don't doubt is what science, the essence of science, I think, is looking at data, looking at somebody might say, there's a causal relationship here. And your first thought needs to be, I don't believe it just because it says it. So, right on.
Yes, sure. I actually think it's a great way to use AI. It's a good application, but like anything, you have to know how to prompt it, and you have to judge and edit the output because it can have bias in it, or it can have problems in it, or it could, basically, if your data is, you can train a model or fine tune it to something you didn't intend. You have to really be good at putting the data together. So just like any other technique, but I think it's a good use for it because it can make you a lot more productive.
Mm-hmm. No. I've never really understood statistics, even though I took statistical mechanics as a physics student. And now I'm starting to understand, all of this stuff is statistical. Ask the AI to explain Bayes' theorem to you, and then you will begin understanding what science is. Did you have a?
So I know this talk is primarily about AI, but are there other recent technologies outside of AI to be aware of? Question.
Nope.
Probably, and I hope what you took from my talk is a little tiny glimmer that I add in there about shiny objects is all the time, and new technologies emerge, and if you jumped on every one of those and down that rabbit hole to try to understand every one of those, you would never get anything done. And I think that figuring out how to wisely use your time with different technologies would be instructive. I can't think of anything right now that is as loud and prominent as AI. But there's also always a lot of little things, some which might be helpful and some which aren't. And I think as you gain experience in your career, you help to you build an understanding about which things are worth exploring, which things aren't. And yeah, you can go down some back paths. Just don't go down too far.
Actually, I did think of something, which is what Bill Fraser and James Ward, who live in Crested View, and I have been working on for the last at least 5 years, and it's called effect systems. And it took me, oh my gosh, they had to drag me behind the car for 4 years before I started to understand it. And an effect is an operation that encapsulates its own side effects. And that's not something that you'll necessarily get right away. But the goal of that, or the result of that, is greater composability of systems. So again, the goal, we're trying to build larger systems. And it took me a while to realize, we were running into another one of these walls that we regularly run into in this field. And the wall was another complexity wall. And in this case, it's how much trouble does it take to change a system that is composed of a bunch of things. And it's very difficult. A lot of programmers waste a lot of time saying, I don't know if you're talking to another system and there's some kind of delay in connecting to that system. Oh, well, you need to put in some sort of a fallback approach. Well, that usually requires a great deal of effort. And programmers, that's just part of their job, right? Well, it's a waste of time and money. And if you can, when you use an effect system, you can say, just plug this thing in here. And because the effects encapsulate their own side effects, you can do it fairly effortlessly. This is we put this book out, I don't know, a year or so ago, but it's called Effect-Oriented Programming. But we're working on a different version of it, and I have since realized that I need to have a better way to explain it. Anyway, that is one thing that I think is it's kind of like when namespaces were introduced, or even compilers or functional programming. Unfortunately, object-oriented programming, which I spent many of my years promoting and teaching, I have decided that was at a dead end. But underneath it were the type systems. And that's why objects look so good, is because they had types underneath it. Just don't do inheritance. That's my opinion. You may be teaching inheritance here. I apologize for that. Avoid it. It's a mistake. Have you thought of anything since then?
Huh?
Oh,
Since inheritance? I
No.
don't think of it.
No.
But I do have something to add.
Oh, that's what I meant.
Yes. Okay. Yeah. Let's just what he just finished with, which is type theory. Right. There you are. Yeah, type theory. And the reason I think that is because, and like proofs, like proving the code is correct, because AIs will be generating a lot of code, and I think it will be like languages might be different in the future. And what might be useful is the stricter types, because then it gives quicker and better feedback to the agent, the AI agent to, iterate. So that's, I think, an area. It's type 3.
Hmm. The current book I'm working on, who knows if I'll ever finish it, but you can find it online if you go to thinkingintypes.com, and it's typing for Python. So anyway, it's a work in progress. So do we have? Yes. Oh,
There's my thing.
yes.
Microphone's going.
I'm not sure if the microphone is good enough.
Okay. I could probably have got that faster. Oh, well. Okay. Perfect.
So the music industry has something really unique that we don't see. They combined the past with the present and future. My dad has a record player that's also Bluetooth. And that got me wondering how much as future scientists and engineers should be thinking about improving the technologies of the past and present, and how much should be thinking about making new technologies for the future.
That kind of seems like a you question, Bill.
Yeah, but I need time.
Yeah, Bill's AI doesn't work as fast.
Yeah.
We'll get Bill's time to compose his answer. But in the meantime, I just want to drag home that the solid CS fundamentals that you all are learning, that's what's going to take you through. So while Bruce can be dismissive of some of the aspects of object-oriented programming, the approach that you learned and the fundamentals that you brought to all of the areas of your study are what are going to help you adapt to new technologies over time and be able to see the opportunity in the old, and may it be improved and applied to the new. I think it's a really insightful question, because there are certainly things that we probably walked away from because it just wasn't feasible. We just didn't have the compute power or the ability to reason about something that now we could do. So I think that's a really insightful question.
Okay, I came up with something.
And I should just add that the process, it was a long process, but realizing that while I was teaching it, there was some part of my brain that was going, this doesn't seem quite right. And the process of understanding why object-oriented programming ultimately is a failure was super useful. So it's not like anyway,
He might not have gotten to that realization had he not gone through that process. It's absolutely impossible for us to know from getting from A to B if we, or from A to C if we didn't go through B. And so take what we're saying with a grain of salt, because I want to make sure that you don't I'm going to make one more little idiom: don't throw the baby out with the bathwater. Do the hard work, and you'll come to your own conclusions. And that's why you're here. You're not in a trade school. You're at a university, and you're learning skills that will take you through your career. And so the foundational elements that you're learning are what you're going to be able to be more skeptical of or less skeptical of in the future.
Don't throw the type system out with the objects.
Okay, what I came up with, that's a really good question. Maybe think. One is I was taught by my parents that it's good to look for the good in people, and I hadn't really thought about it until you asked that question. That I think it's good to look in the past, look for the good in the past, and then when you find something, it's probably helpful to try and find ways to apply that to the present, the future.
No.
With AI presenting such a fast difference in how people learn, and you should try it out and experiment with it, how do you think this is changing the paths from computer sciences to go out of college undergrad and decide whether or not they want to continue with a PhD or like a higher level of education versus just going straight into the industry and getting exposure to that?
I have some experience in that because I did continue going to school, getting a master's degree. I was briefly in a PhD program, which thankfully they canceled. The reason I was in a PhD program is because I thought it would make me more desirable as a consultant. And apologies to all the PhDs in the room, but whenever we have, whenever I have encountered, almost, now this is not entirely true, but PhDs who came into companies that I was with as consultants were remarkably unhelpful. So I'm really glad that I didn't end up. And anyway, it's, I'd say if you're thinking about getting a PhD, you should be thinking about teaching. That's the reason to get it. A master's degree, it's hard to say whether that is, the reason I did it was because I didn't want a job and I could continue going to school. So I ended up being in school for 8 years just because I liked the environment. I wanted to continue experiencing that, which I think is a completely good reason. And then when I came out with a master's degree, it helped me some, but I don't know if that extra two, if you're really focused on trying to, build something, get it, start working for a company or whatever. I don't know. I mean, Diane probably has some more insights about that.
I always have an opinion. So I got my bachelor's degree and I worked for 4 years in industry before I went back to get my master's degree. So at the time that I went back to get my master's degree, I correctly surmised that I would be able to get a different sort of job than the ones that I had been working in. And that turned out to be true. I remember my manager at the time had a PhD in computer science, and before I went back, and he pulled me aside and he said, "Listen, if you want to get a master's degree, more power to you. But if you're going to get a PhD, then you're going to academia. Or you won't find it easy to get a job in industry." And I will tell you that when I interviewed for my first job after my master's degree, I had to get past some skepticism that I was potentially too theoretical. And I was able to do that in the interview. But because it was kind of laughable and not horribly theoretical. But there are lots of reasons why people get masters and PhDs, and probably none of them should be to get a job. I think it's make sure that you are satisfying the kinds that you think that you want, and you can always go back and do later do a master's degree if that's what you want. For me, I had no money when I graduated with my bachelor's degree. I literally finished my master's degree with $20, and I also didn't have the perspective that I ultimately was able to add 4 years later. I had the perspective of working in industry. I was better able to assess what was important and what wasn't. And for me, it was exactly the right time to do it. It's not easy to leave a fully paying job and go back to school. And I had people tell me that I was never going to make that money back, that I lost in those 2 years. That also did not turn out to be true. So, your mileage may vary, and hope you've gotten some insight from that answer.
Yeah, I just want to tell you a story. I went to Purdue, the university in Indiana, and my brother-in-law did also, my sister's husband, and he got some awards from his alma mater. I never have, but he did because he had some success in his career, which was water engineering. And we went to see him, and he went on the stage, and he talked about he had some professor who sort of took him under his wing and was his mentor and said, "You should go to grad school." And he had never thought of it. So when he said that, I thought, well, that was really charming, heartwarming, but I never had that. And I didn't think to look for it. So what I would suggest, it's a very individual decision. You don't have to make it by yourself. Find somebody you click with, like a professor or whatever, and ask and sort of talk about it. And then that's how you make a good decision. Because who knows? I mean, 4 years from now, or about how long, the world may be very different. So you kind of need to find a mentor. I would suggest.
Yeah, I was a physics student, and all of my friends, when you study physics, you go to grad school. You typically get a PhD, and all my friends were doing that, and that's the only reason it occurred to me. And it was like, oh, I can keep from getting a job by going on to grad school. So that's why I did it.
Yeah, I think that's common among people who stay at school for a while. So, one of the reasons I went to PhD school.
This guy who looks like a hippie.
We're just about out of time before the next class, but I think Blake had a question, and then maybe if you guys have any closing remarks from the panel, and yeah,
Good.
hand it up to Blake.
So, do you think AI will be corrosive to critical thinking for the future generations who use it? Because I think, as Bill said earlier, the students who use AI they're getting perfect homework scores, or the test scores are going down. So, I think maybe do we need more limits, or
I have lots of thoughts about how not just AI, but also YouTube videos, change are going to change education. And the like the conference that Andy and Mallory came to, and we had some students, and we hope to have maybe 10 of you at the next one. My vision is that education will be more like that conference, which is very interactive, very self-motivated learning, and removes the really old way of doing things, which is there's lectures, there's tests. You either pass the test or fail. It doesn't really have anything to do with developing your curiosity. So I think what you're seeing right now is the old system being fit for the AI being fit into the framework of the old system. I think the new system will be it, or at least for me, my curiosity has become even greater once AIs have came along, because now the challenge is, how do you formulate a question? It's not about answers. It's about coming up with good questions. And I think after this maybe rough patch, people will get better and better at going, I wonder, or how could this work? Or could we do this? And that's where I believe we're going to evolve.
You asked whether you thought we needed more limits. And I actually think that not having the limits is doing exactly what we want it to do. It's self-selecting out people that are inappropriately using AI to complete homework assignments, and then they're screwing themselves in the end by not understanding the material. And isn't that what college is all about? Is like, you have that freedom to make a bad choice and, not do your homework, or let AI do your homework. And you're ultimately going to fail in your test. So it's different. I have college students, and my daughter was able to she had to defend her thesis at the end of last year, and so the way she used AI was, she asked AI, like, here's my thesis, what are some of the questions that my panel might ask me? And so that's a preparation use of AI, right? Like, that's not cheating yourself out of the experience of understanding the material. And so no, I'm perfectly fine with people using it and ultimately hurting themselves in the future. And like, that's a freedom that comes with being an adult.
Yeah, that's their learning path.
Yeah, I just I guess I'm worried about it because I mean, already it's like kind of hard to tell when a picture is real, and it'll soon be when a video is real, and that's. I mean, I think what AI does, it makes everybody more productive at whatever they want to do, and some people trying to do good things that I would judge as good, and others that try to do bad things, and I don't know how that's all going to pan out. So I don't know about limits or whatever, how to deal with that. But like, for example, that picture Diane had with that blue thing hovering, that wasn't real. That was AI generated. In case you didn't know.
Yeah. All of the photos except the two bracketing, my first slide and my last slide, which were both pictures taken at Pat would pass this week. All the other photos were AI generated, because that is not how I choose to spend my time.
All right. Any closing remarks from the panel?
Yeah, I I guess I felt that, I'm just turned 60 a few years ago. And I thought, my 60s, I just sort of felt like, because I've kind of got enough money to retire, but I haven't got my brain really yet. I'm not done. I thought, my 60s would be my most productive decade. And then AI hit, and I said, wow, now it's like, could really be my most productive decade. And I sort of feel like you guys, I understand it. If I were in your shoes, I'd be nervous about my job prospects. Are those jobs going to be there in 4 years? But on the other hand, you guys can, like, your whole careers are like, you could just be turbocharged. So you could do all kinds of things we never imagined before. So I just wanted to end with a positive note.
Yeah, the problems that the trick, I think, is to look for these unsolved problems, because nobody's, people look at them and they go, it's too expensive, we can't justify it or whatever. But you, with these tools in your hands, can solve those problems. All three of us have, in some way or another, run our own businesses, so we're kind of proponents of that. Diane's done both, and I sort of promote that idea. It's like, yeah, you could work for a big business and they currently will waste a lot of your time in meetings, or you could make something yourself and try finding a customer for that.
And it doesn't have to be one size fits all. I've worked in a variety of industries throughout my almost 40-year career, from, working with really small departments at the University of Michigan around substance abuse research and being able to build applications for them, all the way through to big automotive companies, to, to working at Netflix and understanding culture in a large company. I would not stay at any one of those companies if I didn't enjoy it. The privilege that we have as computer scientists is to be able to learn a little bit about all the different areas that we choose to work in. And wow, is that invigorating and exciting. And, I can't imagine doing the same thing for 40 years. And so I really feel grateful that I've had this very experience, and that I could choose to work for small companies, large companies, my own company, go through the experience of not of building stuff and then not building stuff, and other people building fun stuff, and realizing how jealous I was of that, and that wasn't going to be a good place for me to stay. So, don't be afraid to change your path, because it's out there for you to direct. Nobody else is going to direct that path for you.
And thank you for coming.